Hello again, class. This is part 2 of the first semester review. So in this video, we will talk about questions 11 through 20. So here's question number 11. It says triangle DEF and triangle CBD are similar right triangles. Which statement about the slopes of line segment DF and line segment CD is true? Now, this is one that we talked about in class. For those that were Model A, we did do a demonstration problem of this yesterday. Okay, so this one's very similar to that. We know we find slope 3 different ways. If I give you a t-chart, we know we can find it using delta y divided by delta x. If I give you just 2 points or give you a line and say find the slope of that line, you know that you can do rise over run or fall over run in order to find the slope. But when you're given similar figures, what they're really asking about is, can you use the formula m is equal to y2 minus y1 divided by x2 minus x1? And that's what these two answers down here are talking about. Okay, so what we're really looking for is we've got 2 triangles. I've got this triangle right here. Okay, and then there's another triangle. Let me change colors here. And we're looking for this triangle right here. And what they really want to know is this line right here, which are where those 2 segments are, okay, are the slopes the same for each of those line segments? And that's what they want to know. Okay, so let's see if we can do that. Okay, in order for us to do that, what we need to do is, let me change the right color there, is find the points for each of those points along that line segment. So you'll know we've got FD. So let's look at point F. Well, F is at 1, and this was 7. So 1, 7. C is going to be at 0, 4. And D is going to be at -2, -2. So what we're going to do is we're going to use this formula, the slope formula right here, in order to verify or determine whether or not the slopes of these 2 line segments are the same. Okay, so the way we do that and the way I've taught you in class is the first thing that we do is we identify our points. So what we're going to do is we're going to use DF and CD for our points. So the first line segment we're going to use is DF. So that means I need this point and this point. And the first thing I asked you to do with that is identify your points. So I'm going to call F1 and I'm going to call D2. The only reason why we do that is because that tells me x1, y1, x2, y2, so that I can plug it into our formula up here. Okay, so let's see if we can do that with this first one. So I'm going to do y2 minus y1, so that's going to be -2 minus 7. So -2 minus 7, okay, because it's always minus, divided by, and then I do the x's, -2, 1. So -2 minus 1. So we look down here and we see if that is there. -2 minus 7 and -2 minus 1. Well, here's where it's got the 7s, and it looks like the 7 is first. So could I take this point right here and just flip the numbers? 7 minus -2 and 1 minus -2, and would it be the same? Yes, it would. Okay, so this is good. Now, you'll notice in B, what they did was they've got the 1 minus -2 on the top, and then the 7 minus -2 on the bottom. So what they did is they put the x's on top and the y's on bottom. So that automatically tells me that B is out. But A is good. Okay, so now if we were to look at the other points, which is CD, okay, we're going to do the same thing. Okay, now, since they reversed it on the first one, they're probably going to reverse it on the second one as well. So we'll see. So I need point C and I need point D. So that's going to be this point and this point, the 2 bottom ones. Okay, so what I'm going to do is, again, I'm going to label this one 1 and this one 2. Okay, so we end up putting -2 minus 4. That's because that's my y values. And then I need to do my x values, -2 minus 0. Okay, now, the one that we're looking for, you'll notice that they actually did put it the same way we did there. -2 minus -4, -2 minus 0. So it is correct. So both of those are correct. So it says the slope of line segment DF is equal to the slope of line segment CD because the slopes can be determined by using the expression. And then we've got those 2. So A is the correct answer. But let's look at C and D, see if we could automatically eliminate those. The slope of line segment DF is greater than the slope of CD. So if we were to look at those two right there, they look like they're exactly the same. So the slope is not going to be greater, so it's going to be out. And D, the slopes of line segment DF and CD cannot be determined. Well, using this formula, it can be determined. Okay, so the correct answer is A. Okay, so let's move to the next page. Number 12. The graph shows the relationship between the time and distance a cyclist travels. Which of the following best describes the slope of the line? Oh, and it looks like I've got the question in there twice, and that's okay. Which of the following best describes the slope of the line? Well, we know that when we're dealing with the slope of a line, we pick two good points, and we find rise over run. Well, the first good point is right there at 0, 0. And if we travel up this line, the next good point is going to be right there. Okay, so I'm going to do rise. So right there is 30. And my run is, okay, we look at the thing there, and it's 2. So we get 30 over 2. We simplify that. We get 15. So it says, A, the cyclist travels at a speed of 1.5 miles per hour. No, because we've got miles per hour. So that's going to be our labels. So that's how we look at that. Okay, so this basically is 15 miles per hour. So we look at B, the cyclist travels at a speed of 15 miles per hour. Yes. Okay, and you could have eliminated all the other three. Okay, so let's look at the next one. A supermarket advertises a new product by offering samples to customers. The table shows the number of samples distributed each hour. At what rate does the supermarket distribute samples? Now again, when we talk about rate, all we're really talking about is slope. So when we looked at that previous problem, it said the same thing. Okay, this one talks about slope of a line, so we understand slope, rise over run. And this one we're talking about rate, which is another word for slope. What is the slope? Now we know in a table, we're going to use delta y divided by delta x, but we got to remember which one is x and which one is y. Top is x, the bottom is y. Most of the time, that's the way it is. Number of hours, number of samples. The number of samples depends on how many hours you work. Okay, so what we're going to do is we're going to do delta y, which is the difference here. So we're going to do 114 minus 76. And if you actually do that math, if we actually do it, let's see, we get 14 take away 6, we get 8. And then this becomes 10, we get 38. And we're going to, so our top number is 38, and we're going to divide that by, what is the pattern on the x values? 1. Okay, so how many things do we give out each time? 38 per hour. So that means my answer is not A. I circled the wrong one there. My answer is actually C, 38 samples per hour. Okay, next one. Okay, doing the same thing. It's another T-chart. The table shows the cost of buying X tickets to a school play. If the data are graphed on a coordinate grid, what is the y-intercept of the line that passes through these data points? Now, we've got to remember, okay, when we do the delta y divided by delta x, and it gives us our x and our y, we do our delta y and our delta x, and we look at that pattern, we're finding slope. But what is the y-intercept? Where's the y-intercept found in a T-chart? The y-intercept is found at the 0 value. When x is 0, what is the y value? Okay, so that's what we're looking for in this particular one. So the first thing that we need to do is we need to figure out what is our slope so I can figure out how to count backwards by 1. Because remember, slope is a unit rate, how much for 1. Okay, so we find our pattern on our y side, which is going to be 2125 minus 850. And if we subtract that, we end up with, let's see, 5 here. And we end up with, if we borrow right here, we get 7. Okay, and then I've got 20 right here, which gives us 1275. Okay, so that means it's 1275, and that's going to be out of, and then our pattern on the left is 3. So 1275 divided by 3. So if I actually do that division, that actually gives me 4.25 for 1. Okay, so that means for every 1, it's 425. So what I have to do then from this 850 is I got to go backwards to 1. So if I subtract 425 from that 850, I get 425. And if I go back one more, I actually end up with 0. So what is my y-intercept in this particular problem? My y-intercept is actually D. Okay, but notice, They actually gave us the slope in the problem of 425 because they think that's going to be a common answer. And we'll probably find out that it will be. Okay, but the correct answer is actually D. Number 15. A discount music store has a one-day sale on all vinyl albums. In order to purchase from the store, each customer must have a yearly membership. How much does the music store charge for a yearly membership? Well, again, if we find our pattern on the right and our pattern on the left, we're going to find slope. But the yearly membership, what they're going to refer to is that adding number, which is the y-intercept. Okay, so in this particular problem, we got y is equal to mx plus b. Well, this is going to be the amount per album, but this b is going to be the amount for the membership fee. Okay, so the first thing we have to do is we got to find our slope in order to determine this. So we're going to find our pattern on the left. So we're going to do 5750 minus 35. And when we do that, we end up with 2250. Okay, and then we look at our pattern on the left, and our pattern is 3 in this particular case. So I'm going to divide this by 3, 2250 divided by 3. So we find out that our slope, oops, sorry about that. We find out that our slope, our m value, is actually equal to $7.50. $7.50. So that's how much each album costs. Now, how would I find my b then? Okay, well, this is where we take our points. So I can take this point right here. Okay, and I can go y. Well, this is my y value of 35 is equal to my slope, 750, times, well, how many albums did I purchase? 4 plus b. Okay, and then we solve. Okay, so we do 750 times 4, and you end up with 35 is equal to 30 plus b. And we ask ourselves, what do I need to add to 30 in order to get 35 as an answer? Okay, and so that tells me that b is equal to 5. So my membership fee then is $5. Okay. Number 16. A customer has a credit card that charges 18% simple interest every year. How much interest will the customer save by paying off a credit card debt of $5,000 at the end of 1 year instead of at the end of 3? Okay, so this is a simple interest problem. So that means we pull out our simple interest equation. I is equal to P R T. I for interest, P for principal, R for rate in a decimal form, and T for time in years. Okay, so we end up with I is equal to, principal is $5,000. Now this one is a two-part problem because it says, how much would you save, how much would the person save by paying off the principal of $5,000 at 18% simple interest at the end of 1 year instead of 3 years? So we've got to find how much for 1 year. Okay, so that would be interest is equal to 5,000 times my interest rate of 0.18, not 15, times 1 year. And if we do that, we end up with an interest of $900. That's how much interest you'd pay. Okay, but now you also have to do 3 years. So interest is equal to $5,000 times 0.18 times 3, and that gives me an interest of $2,700. So now what we want to know in this particular one is how much would I save if I paid it off in 1 year versus 3. So that means we take the $2,700 and the $900 and we subtract those to get $1,800. So how much would I save? $1,800. Okay. Question number 17. Now this is the only one that we haven't talked about yet. Okay, and we will talk about it this next week. It says a scatter plot shows the relationship between the number of calories and the number of grams of fat in food items at a fast food restaurant. Based on the scatter plot, what is the best prediction of the number of calories in a food item that contains 27 grams of fat? So we've got fat here along the bottom. We've got calories along the side. And what we basically do with a scatter plot is we look at the trend. Okay, and we put what we call a line of best fit down the middle of it. Okay, so we kind of do an average line here of all these points right here. And we look at this line as it goes up. It kind of goes just about like that. Maybe a little bit, it's a little bit off. Let me try that again. Actually goes about like that. Okay, So what we want to look at then is, what would it be at 27 grams of fat? So if we go up here, my 27 is going to be about right there. So based on my numbers, which one would be the best one in line? So along the 27 is about right in that area. So we've got 580, so it's a little bit above 580. So which one is the best? A. And that's what we're going to talk about next week when we learn about scatter plots, is how do we determine that trend, and how do I actually find the equation for that line that we just drew through the middle of it. Okay, so that's what we're going to be looking at. Question number 18. The value of y varies directly with x. When y is equal to 8.4, x is equal to 3.5. What is the value of y when x is equal to 7.7? Okay, so this one is a direct variation problem. And I told you with direct variation, it's just a proportion. You just set up a proportion. Y over x is equal to y over x. So you'll do 8.4 over 3.5 is equal to y over 7.7. Because I did y over x, and now we just solve it. Okay, so what we would actually end up doing is we would take the 7.7, we'd multiply by the 8.4, and we would divide by the 3.5. And if you do that, you end up with y is equal to 18.48. Okay, so correct answer is A. That's all you do. So y is equal to 7.7 times 8.4 divided by 3.5. So using your calculator, that becomes a very simple question. Question number 19. Which set of ordered pairs represents y as a function of x? So this one's just dealing with functions. Okay, so we know in functions, king is the x value of the coordinate. And the x value must be unique. Okay, so we look at our sets. We look at the x part. 2, 4, 6, 8. They're all unique. Is that a function? Yes. 0, 1, 1, 2. Uh-oh. We've got a double 1, so that makes that one not a function. 3, 3, 4, 4. We've got a double on the 3s and a double on the 4s, so that's not a function. 1, 1, 2, 2. Again, we got double 2s and double 1s, not a function. So this one is one of those gimme kind of questions. Functions, we're only looking at the x values. The x values must be unique in the coordinate. And last but not least, Pythagorean Theorem. When three squares are joined at their vertices to form a right triangle, the combined area of the two smaller squares is equal to the area of the largest square. Which three squares are an example of this relationship? Okay, so an area is always going to have a centimeter squared. Okay, so we know they're squares, but it says that it has a combined area of the two smaller squares is equal to the area of the larger square. Okay, so in A, this 10 centimeters squared is already an area. So when you remember, it's A squared plus B squared is equal to C squared. So this would be side lengths of a square. Okay, if we were to look at this A squared, that's going to be A times A. Well, when we square it, that already gives us an area like that right there. So this says 10 plus 7, because this one is also an area, is equal to, now this one's not an area. The 12 is not an area. So we square it. And 12 times 12 would be 144 centimeters squared. So is 10 plus 7 equal to 144? No, it's not. Okay, so that tells me that A is not correct. Okay, so then we go to B. Well, this 8, it's not an area, so we do 8 times 8 to get 64. That would be centimeters squared. The 4 centimeters is an area, and the 80 is already an area. So this one is 64 plus 4 is equal to 80. Is that correct? No, it's not. Okay, C, well, this 7 centimeters squared is an area. This 7 centimeters squared is an area, but this 7 is not. So we square it. 7 times 7 is 49. So this one would be 7 plus 7 equals 49. Is that true? No, it's not. So that means D must be the right answer. But let's prove it. Okay, so we've got this 11. Well, it's already an area, so it's good. The 5, it's already an area, so it's good. But this 4 is not. So we do 4 times 4 to get 16. So is 11 plus 5 equal to 16? And yes, it is. So D is the correct answer. Now, that's kind of the end of our semester review. So we've talked about all 20 of these questions, and these are all the questions that are kind of examples of some of the topics that are tested on the STAR test over the concepts that we covered during the first semester. The second semester, we're going to cover a whole new set. Okay, but we're still going to be using a lot of the same skills that we learned in the first semester. Okay, so all of the stuff that's on this semester review, I need you to remember because you will be tested on it. Okay, so until next time, I'll see you later.